Students, we are going to understand the velocity time graph. Okay, so you can see here, this is the velocity time graph, and if you know, the velocity means the change in no you can say change in the speed, no in the direction with the time. Okay, the direction is required in case of velocity. For motion along a straight line, velocity time graph and speed time graph are the same. So if it is the straight line, right? If it is the straight line, so whether it is velocity time graph or the time, speed time graph or the velocity time graph, both are the same. Now, to plot a velocity time graph, we take the velocity along the y-axis and time along the x-axis. Velocity time graph under the different condition are velocity time graph for uniform motion. Uniform motion means the change in velocity is same in the same interval of time. That is what? For a linear uniform motion of a object, the velocity of the object does not change with time. So velocity time graph is a straight line parallel to the time axis as shown in figure. So this is coming to the straight line that you can be able to understand. Now see the point, what the important point statement are there. Determination of distance covered. So from the velocity time graph, how can you determine the distance covered, right student? So this is very important one. In a velocity time graph, the distance covered or the magnitude of the displacement is given by the area enclosed by velocity time graph. Area enclosed by velocity time graph and the time axis. This is what the area enclosed. That is what the distance traveled. We know that for uniform motion along a straight line, v is equal to s by t. So s is equal to b into t. In other words, the product of velocity time gives the displacement of the moving object in that time. Magnitude of the displacement is equal to the distance covered by moving object along a straight line. Hence, area enclosed by velocity time graph can be taken as the distance covered by the moving object. Now see this one. Let an object move with the constant velocity v between time t1 and t2, position p and q on the graph correspond to the t1 and t2 respectively. Draw the normal PSQR from the point P and Q on the time axis. The distance moved by the object T2 minus T1. So S is equal to what? PS into SR. So you can see this is the PS and this is SR, the area of the triangle. Okay, area of the triangle PQRS, that is. Now you see PS is how much, student? This is the PS. PS means that is velocity v, and this is what, that is T2 minus T1. Okay, this one. For uniform motion along a straight line, the magnitude of displacement of the distance covered by object is given by area under the velocity time graph during that period of time. So this is. Now let's try to understand one problem. A student is running on a straight track with the velocity 5 meter per second. With the help of the graph, so how much distance is covered by him in a minutes. Okay. So he is running in the straight line 5 meter per second. With the help of graph, we have to tell. So as student is running with the constant velocity along a straight line path, the velocity time graph shown in figure 20, the graph is straight line AB parallel to the time axis. So AB is a parallel to time axis. So this is a T1, so this is going to be T2 and this is B. So distance covered by is the student in time 60 seconds. So area under VT curve. So area of ABCD. So OA into OC. So OA into OC. So OA is 5 into 60, that is 300 meter per second. So this is all about the answer. Now velocity time graph for uniform acceleration. The velocity time graph for accelerated motion of an object initially at rest is an inclined line passing through the origin. So this is what. So this is the time and this is the velocity, right? Now you can see this is the uniform acceleration they have. Object initially at rest, let's motion of an object be uniformly accelerated along a straight line. Magnitude or velocity of the object goes on increasing uniformly with time. So v proportional to t. The velocity time graph for uniformly accelerated motion can be used to find the magnitude of displacement or the distance covered by distance covered in a given time. So that is the acceleration. Calculation of uniform acceleration. Consider 2 point P and Q on the velocity time graph corresponding to T1, T2, velocity V1, V2 respectively. Draw a normals P, T and QS from the point P and Q. So using the triangle PQ and R, OR is equal to V2 minus change in velocity, PR is T2 minus J1. Acceleration change in velocity upon time, so V2 minus V1 upon T2 minus T1. So QR upon PR, so slope of velocity. For uniformly accelerated motion, the slope of velocity time graph gives the value at uniform acceleration of the object. Calculation of distance covered or the magnitude of the displacement. Consider 2 point P and Q on the plot corresponding to the time T1, T2 and velocity V1, V2 respectively. Draw normals PT, QR from the point P and Q time axis. The distance covered or the magnitude of the displacement during period of time is given by the area under the velocity time graph of the object. The distance covered by the object in time T2 minus T1. So S is equal to area PQRST. Area of the rectangle PRST plus area of the triangle PQR. So S is equal to PT into TS and half base into height. So this is. Now let's try to solve the numerical, student. So it will be very much helpful to you to understand. The velocity of the vehicle in meter per second. Different time is given in the table A, vehicle running in a straight line. So velocity 0, 0, 10, 10, 20, 20, 30, 30, this is there. Find the value of acceleration of the vehicle from the graph. So that is the graph, so the uniform accelerated motion. Let us point P and Q corresponding to time T1 and T2. Okay. So 20 they are taking and T2 60. They are going. Now the velocity V1 20 and V2 60, then acceleration QR upon PR. Acceleration QR upon PR. So V2 minus V1, T2 minus T1, so 60 minus 20, 60 minus, so that is 1 meter per second square. For linear motion, speed time graph are exactly the same as velocity time graph. However, along y-axis speed plotted instead of velocity. Object initially in motion. In this case, the velocity time graph of uniformly accelerated motion in a straight line inclined to the time axis, but straight line does not pass through the origin O. Velocity time graph such as motion is shown. So acceleration is equal to change in velocity upon change in time. So A is equal to V2 minus V1 upon T2 minus T1. So A is equal to QR upon PR. So this is the QR upon PR. This is velocity time. So distance covered by object in time T2 minus T1, area of PQRSTP. So area of the triangle PQRST, area of the a rectangle and area of triangle. So this will come. Next one, velocity time graph for uniformly deaccelerated motion. So let's the velocity of the object moving in a straight line decreases with the time. Velocity time graph for such a motion is shown in figure. Acceleration in this case is negative. So A is equal to B2 minus B1 upon T2 minus T1 PQ PT upon TQ. The distance covered by the object in time T2 minus T1. So area PQRSTP, area of the triangle PQRST plus area of the triangle PQT. So TS into SR plus half PT into TQ. Okay, this is what velocity time graph from non-uniform motion. Let's an object along a straight line with the non-uniform acceleration. The velocity of the object rises or falls without any uniformly time. The velocity time graph for such a uniformly accelerated motion is shown in figure 25. Okay, the area under the velocity time graph gives the distance covered, the magnitude of displacement in the given time. For a motion along a straight line in a given direction, magnitude of displacement is equal to the distance covered. In such cases, distance time graph and the displacement time graph are same speed time graph, and velocity time graph are also the same for such a motion. So this is all about the velocity time graph. I hope it will be clear to you. Thank you so much for watching, students.